Okay, we're going to look at our next measure of central tendency called the median. The median is the middle data value of a set of data values after they've been arranged in numerical order, so in ascending order from left to right. So for example, if you look at the quiz grades 8, 7, 9, 9, 9, 6, 10, 7, 5, and we have to find the median, we're going to list these data values in increasing order from left to right. So it looks like this: 5, 6, 7, 7, 8, 9, 9, 9, 10. So even though we have a repeat of 7s and a repeat of 9s, we're going to include all of them in this list. Now what we do is we look for the middlemost number. So if you have this on paper, it's easy. You can start crossing off numbers from either end. So if you cross off the 5 and 10 and then move in, then you cross off the 9 and 6, move one in, you cross off the 7 and 9, move in, cross off the 7 and 9, and you're left with a center value of 8. That's your median. The median is the middle grade, and it is an 8. Now, because we started with exactly 9 data values, 8 finds itself right in the middle. It's basically the 1, 2, 3, 4, 5th data value. Now, what happens if we add another score of 10? So now we don't have 9 data values, we actually have 10 data values because we have this additional score here. We're going to use the same method. We're going to put the scores in order in increasing order from left to right, so in ascending order. We've got that 10th data value right here, and when we start crossing off digits on the right and left, so cross off the 10 and the 5, then cross off the 10 and 6, then cross off the 9 and 7, cross off the 9 and 7. 8 and 9 are the two data values that are left in the middle. So when this happens, you don't pick 8 or 9, you actually take the mean of those two numbers. So whatever those two numbers are left in the center there, you will take the mean of them, which means add them up and divide by 2. And when you take 8 plus 9 and divide by 2, you get 8.5. So the median is the mean of the two middle grades when you're dealing with an even number of data values in your data set. Okay, so if there are an even number of data values, the median is the mean of the two middle values. The mode. This is the third measure of central tendency. The mode of the data set is the data value which occurs most frequently. A data value may not have a mode, or it may have more than one mode. A distribution is called bimodal. A bimodal distribution if it has two data values that appear with greatest frequency. If a distribution has no mode or more than two modes, then the distribution is called non-modal. Okay, so we have a mode, meaning the number that appears most frequently. If we have two numbers that appear most frequently or at the same frequency, it's called a bimodal distribution. And those two numbers would be two different modes. If we have three or more numbers that appear at the same highest frequency, it's called non-modal. And those three numbers are not modes because it's a non-modal distribution. If we have no numbers that appear if no number appears at great frequency, then it's also non-modal. So for example, if every number in the distribution were unique, where no one number appears more than once, it would be a non-modal distribution. Okay, so let's find the modal test score for the following 8 test scores. So we look at the numbers 65, 75, 45, 90, 75, 68, 85, and 60. And we try to see if there are any numbers in this data set that appear with more frequency. So we can see here that 65 only appears once, 75 appears twice, 45 appears once, 90 appears once, 68 appears once, 85 appears once, and 60 appears once. So 75, because it appears twice, is considered the mode, the modal test score. Now, let's look at this distribution. We have a 4 that appears twice, 6 appears twice, 10 appears twice, and it looks like the rest of the numbers just appear once. Well, it doesn't mean we have 3 modes. If we have something where there are 3 or more numbers that appear at the same frequency, then we say the distribution is non-modal. So this distribution is non-modal. Okay, let's look at an example, a real-world example involving salaries or incomes. The small community of poor-rich is applying for federal aid. One question on the application requests the average family income for the community. The following data are the family incomes for the 5 community residents. I'm sorry, I should say for 5 community residents, because this is considered to be, let's see, is this a sample or not? You know, I'm not positive if this is supposed to be a sample. It doesn't matter because the mode is calculated in the mean, the median, the mode are calculated in the same way. Okay, we are going to look at these 5 values and we're going to calculate the mean, the median, and the mode, and we're going to decide of the 3 numbers which one depicts the typical income accurately. So looking at those 5 numbers, we calculate the mean by adding them all up and then dividing by 5. So if you add them all up and divide by 5, you'll find that the mean is 58,000. Okay, so you're adding up 25,000 plus 20,000 plus 200,000 plus 30,000 plus 15,000, and you have a mean of 58,000. Now, does anything strike you as odd when you look at these numbers? Does anything come out and alarm you? Well, you should note that the 200,000 is way above the other data values. Looks like the incomes in this community are generally in the 20s. There's one that's 30, they're in the 15,000 range. And then we've got this one income at the $200,000 range. So you can probably estimate that this $200,000 income is probably not typical. The mean came out to be 58,000. Okay. The median came out to be 25,000. If you order these numbers from least to greatest, and then the middle number is 25,000. There is no mode because none of those numbers appear more than once. Now, of the mean and the median, which number is more typical of the data values in this distribution? Is 58,000 more typical, or is 25,000 more typical? And the answer here is that the mean income of 58,000 is greater than 4 of the 5 family incomes and does not represent the typical income of the community. So 58,000 would not be a typical number for income in this community. So you would not pick the mean for this answer. The median, however, the median of 25,000 more accurately depicts the typical income level of the residents since it's not sensitive to the extreme high income within the community, meaning that it's not affected, not sensitive to the $200,000 income that was part of that data set. Okay, $25,000 is closer to 4 of the 5 values, so it's reasonable to group the 25,000 with the 25,000, 20,000, 30,000, and 15,000. That would be a typical income, whereas 58,000 is not close to any of these. Now, what's happening in our calculation that's creating that 58,000? Well, it's happening because 200,000 is a very large data value compared to the others. And when calculating the mean and incorporating a very large data value, larger than the rest, the mean calculation turns out to be a little bit greater than the median.